Please take your seats. We have an exciting panel on bare metal networking, and let me invite Bert to, or Altaf to, as the moderator.
Thank you, Deepak. Hello, everyone. How are we doing? I'll give it maybe a few seconds for folks to settle down. Well, that was a great session on container networking that we just had, and I think we're going to have a very interesting and insightful session on bare metal networking now. I'll first maybe introduce myself, and then we'll have our panelists introduce themselves as well. My name is Altaf Tambawala. As you can tell, I work for Microsoft, and I'm a product manager for Azure Networking. Anand, would you like to introduce?
Sure. Hi, my name is Anand Ramakrishna. I'm on the engineering side in Azure, responsible for bare metal workloads.
Hi, my name is Boon Ang. I work for VMware. I work primarily on networking data path on ESX hypervisor, as well as NSX networking virtualization product.
I'm Bert Molinari. I'm an engineering manager also in Azure. I'm Anand's counterpart on the networking side for bare metal.
Cool. Well, thank you all for coming and taking time out from your busy schedules to, I think, inform us on what I believe is a very rapidly evolving space within the cloud. Before we get started, a quick administrative remark. We want to keep this as interactive as possible. So feel free to flag yourself, raise your hand, or get to a microphone as we go through the panel session. I think we'll try and use sort of some of the questions for a general chat on the panel, and then keep some time for Q&A at the end, but feel free to get your questions out as they come along as well. Before we jump into the questions, I sort of wanted to preface the discussion to sort of set some context. The title of the panel session is Bare Metal Networking, and I think the bare metal sort of implies direct access to the underlying hardware, which there are cloud offerings where that is true. But I think the purpose of sort of this discussion is to really key in on some specialized workloads that are typically required to be run on-prem because they run on sort of purpose-built hardware and specialized software. And we sort of want to discuss the implications of bringing those niche workloads into the public cloud and sort of integrating them into the cloud along with the rest of sort of the cloud services that we offer. And so sort of with that, let me open it up with a very, I think, basic question as to sort of why should we do this? I mean, what's driving the need to bring in and host these specialized workloads that run on proprietary hardware and software and integrate that into the public cloud? I don't know, Bert, if you want to start with that. And
Sure. So I do a lot of recruiting on this topic, so I've got a kind of a bit of a road answer for it, but I think it tells a good story. So if you look back over the last few years, companies are running stuff on-prem in their IT data centers, and the cloud comes along at some point. They start to move workloads into the cloud. So the simple example I use is Shell Oil. Let's say they've got a time and reporting tool that tracks employees' time off. It's basic architecture, application server, and a SQL database. So at some point, cloud comes along, whether it's Amazon, Google, or Microsoft, and they move the application onto a VM, they move the database onto a virtualized SQL server. They do more and more of that, and over time, these racks of servers that are sitting on-prem in their data centers start to bleed off applications, and they can turn that thing off, and they're really happy because they don't have to spend money on the hardware anymore or dealing with that stuff. They can focus a little bit more on their core business. That happens over the course of a few years. Then they start to look around their data center, and Shell Oil looks around their data center. Perhaps they have a Cray supercomputer there. Why do they have a Cray supercomputer? Well, they need to build an oil rig, and they need to figure out where to put it, the oil rig, and if they get it wrong, it's going to cost them a lot of money, so they need to do a lot of heavy supercomputing to figure out where to put that thing. They want to get rid of that thing out of their data center because actually operating the Cray supercomputer isn't core to their business, but writing the applications on top is core to their business. So they go around to cloud providers and they say, hey, Microsoft or Google or Amazon, can you take this Cray supercomputer and put it in your cloud? And we want to help them. The challenge is it's not something that's native to the cloud because cloud's all about these physical layers that are abstracted out with virtual layers. And a Cray can't be virtualized. The magic in the Cray is in the hardware. So the driver for this is that businesses love what they've seen from the cloud so far, and they want to do more. They want the cloud to evolve to take on their mission-critical applications that are not easily virtualized. So that's kind of what's driving the business from what we see. And it creates a lot of interesting technical challenges, which we can kind of talk about. But that's the main driver, is that it's the next evolution of the cloud. I don't know if you guys have anything else you want to add to that.
For me, the bare metal services in the cloud that I'm most familiar with is actually what VMware does with bare metal servers from big cloud provider. We are actually able to run a hypervisor on it and then provide a service to our customers. So it's not as much specialized hardware or workload as such, unless, well, you can think of our hypervisor as perhaps a specialized workload. Without that, we'll have to probably run nested virtualization, which is functionally possible, but performance-wise, it just doesn't make a lot of sense. So that's what I'm most familiar with. In addition to that, we also offer things like high-end desktops where CAD and engineering tools are running, and that for all those very high-end GPU is needed and stuff like that. So direct access to the kind of hardware from VMs is necessary. And those have advanced to a point where you can, in fact, still do some kind of checkpoint restore or migration of the VMs. So I think increasingly, customers like the value proposition of moving things to the cloud, the elasticity of it, not having to own hardware for a long time or to be able to essentially timeshare. All those very good value proposition for customers. Thanks.
Yeah, I mean, I think it's just kind of to pile on a little bit into that. I mean, when I talk to customers, it's exactly the same sort of thing where customers basically want cloud economics, agility, elasticity, but for these what you'll call specialized type workloads that perhaps are not exactly designed for that, and that's certainly not how they've been operated in data centers over the past decade or so. And so I think that's kind of where a lot of the technical challenge comes in, which is how do you meet those expectations of customers on technology that wasn't necessarily designed ground up to go meet those expectations.
Great. Well, so I mean, understanding that there's a need for this, just for all of us. I mean, why should we talk about this though? I mean, how big is this space, or how big do you see this evolving over the next 2 to 3 years, in both from both sides, from a customer demand perspective as well as from the perspective of the capabilities in the cloud to accommodate such workloads? Where do you see that? Where is that today, and where do you think that's going?
You want to take that
Anyone?
one?
Sure, everybody's looking at me, so I'll take it. So in terms of opportunity, I mean, the opportunities for all cloud providers is really big. So if you look at SAP as an example, I actually looked this morning, they're one of many that are in this bucket of bare metal services, and their market cap's huge. It's a $150 billion company just by itself. VMware is another $70 billion company all by itself. There's a lot of opportunity on the business side to get more money coming into cloud operators. And as Anand was saying, there's also, I think, a chance for cloud providers to evolve their offerings to support more mission critical workloads. And on the vendor side, whether that be SAP or Cray or VMware, there's a chance for them to evolve their stuff to get onto clouds. One thing was interesting for me, I went to an SAP conference probably February of this year, not knowing a lot about SAP going in, and the main message I heard from SAP was, as a vendor of their software, was get onto the cloud. They're pushing all their customers onto the cloud, and it makes a lot of sense because from their side also there's a lot of agility that they get, because today they have to support end versions back of SAP on-prem because some customers, like the California government, doesn't want to update their SAP database for 5 more years, so they have to run something that's 10 years old and then support that. If they can get their customers onto a cloud, they have the agility to go change under the hood and get a lot more new features out to their customers a lot faster with a lot less friction. They've even built their own cloud to the point where they want their customers to get in the cloud. So that's kind of the way all this stuff is going, is more and more agility, I think, for all involved, the customers and the vendors of the software as well.
Moon or Anand, do you have a comment as well on that?
Yeah, I think like what Brett has said earlier, a lot of customers want to focus on what their core value proposition is. and also not have to own something that they only use part of the time. So all those are very good motivation. And then for software vendors, there's also the additional motivation that when you manage a software in the cloud and you're the one managing it, you get to change things underneath. You don't have to support end versions, and end versions is a huge cost for QE testing and things like that. So all those are a huge motivator. It's a win-win for everybody.
Yeah, I mean, I think you asked the question kind of earlier, how big is this? How significant is this? I mean, I guess I would kind of respond back in a very simple way that just simply says, like, how many mission-critical applications, how many mission-critical systems are actually there across the world that are currently deployed and that are currently used by enterprises, by customers, by users. The vast majority of them are not on the cloud today, and all of those people are still looking at exactly that cloud value proposition, going, "Hey, how do I get that value proposition for these other applications too?" So I think it's a very significant trend.
Great. Well, so I think Anand, you sort of touched on it earlier about the fact that this sort of seems complicated, right? I mean, the way I think about it, the inception of the cloud was sort of based on the premise of sort of off-the-shelf hardware that's virtualized, and you have workloads and software that you put on VMs. I almost feel like this is sort of a 360 on that paradigm, where we are saying now that, well, now, you also have these sort of purpose-built hardware, software solutions that have been running on-prem, and we can take them and put them into the cloud as well and integrate them such that the experience from a customer standpoint is seamless, whether they're using sort of native cloud services or these workloads. It sounds like the public cloud wasn't sort of designed for this initially. So how are we addressing that in terms of making sure that the integration is seamless? What sort of challenges do we have?
Yeah, I mean, how are we addressing it? Through lots of hard work.
Absolutely.
I think the challenges are actually kind of up and down the stack. I would say there's a bunch of challenges at the infrastructure, in the sense that some of these workloads, and specifically from a networking point of view, some of these workloads are designed, tuned to work with what I'll call older ways, let's say, of kind of configuring and using networks that perhaps are not as common in cloud application patterns. And so then there's a bunch of work needed to just go enable that type of capability, which doesn't even exist, down at the infrastructure level. And then obviously then there's the enabling it, but then there's also the tuning it and then operating it, kind of getting really good at that. Then kind of moving up the stack a bit more is down up even at the application level. There's kind of again additional tuning and whatnot that has to get done to go deal with the fact that you now are running on some other kind of infrastructure than what it was originally designed to certainly run, and so then there's more adaptations and perhaps that might need to be done at that level, and so on and so forth. Like, I think it's like the analogy I was giving somebody earlier was, imagine you have a building that was built 10 years ago, and it's a fine building, it works great, and then you decided that you were going to move that building over there. Even if that other place over there is stable, it's going to be a little shaky while you go figure out all of the various aspects and assumptions that were different.
Just a question on that.
Yes.
The original question seemed to imply that for these bare metal servers, there's going to be a lot of specialized hardware to support the bare metal servers. Is that where you guys see this going, or do you see this really as being more standard servers that you're deploying, and it's really just the isolation and the software that uniquifies it?
I think it's both. I think we talked about kind of two good examples here, and there's a lot of examples. Cray on the one hand is probably always going to be specialized hardware. SAP on the other hand, maybe not so much. So it's a big, wide world, and when we say bare metal, it's covering, as we're saying, this whole ecosystem, all these companies that have built all these different applications. Some need special hardware, some don't, so I think it's a bit of a mix at the end of the day, and I think we actually probably need to support both.
Yeah. So just to expand a little bit on the networking front, as you move all this workload into a shared environment, I think the usual need to put in sufficient layer abstraction so that you get the functionality you need, the security, sandboxing or whatever that needs to be there, as well as for some of this workload, there's a performance requirement as well. And getting all three of them together will be interesting. One thing about physical bare metal, things running on bare metal in a customer's premise is that there's a lot of manual engineering that can be done. I mean, people sometimes make sure that your database and clients all connect to the same switch, so the path is really short. Things like that will get interesting as we move them into a shared environment.
Yeah.
And also just a side note, when you're talking about CRAE, the thing that came to my mind, and this is going to date me, is the Connection Machine 5. I don't know if how many people still remember Connection Machine. Remember Jurassic Park and that panel of red LED? That's the Connection Machine 5. And I remember Charles Isaacson talking about the all fall down mode, make it time shareable and stuff like that. Yep. So that was a long, long time ago. But anyway.
And just to riff a little bit on what both of you said about specialized hardware and performance, I know a problem Anand and I spend a lot of our time on is performance for SAP. And it ties both of those themes together, where a customer has gone and taken SAP and they've found some appliance, a Cisco FlexPod, which is certified to run SAP. They deploy it on there and it works. And exactly as Boone was saying, the application server and the database server are under one switch. There's not a lot of networking. So now all of a sudden you want to put that into a cloud. Stuff is moving around in a cloud. Part of the agility of the cloud is that you can move things around. So you may have your VM running the application over here and the server running the database over here, and all of a sudden network latency just exploded because the basic assumptions that are there aren't true anymore. To the point where even potentially SAP software changes. We've kind of actually whiteboarded some potential, we can imagine there's a software engineer at SAP who writes code a particular way under the assumption that the network latency between these two components is really, really low, because you have to be that low to be certified for SAP. And all of a sudden you put that into the cloud and all these things start to break.
Yeah, I mean, I think I think that it's not just even the static side of it, there's even the jitter side of it as well. Because again, in the cloud, one of the things is that, this stuff is dynamic, which is exactly how you get the elasticity. But then along with that elasticity comes jitter problems, which, how do you go give consistent performance, over a period of time, is also kind of a really challenging thing to go do as well.
Great. Well, I guess, this sort of is a networking event. So, looking at sort of some of these challenges, with what we have from networking, how can sort of networking help to solve some of these challenges? I mean, in which ways does networking address some of these challenges in making sure that connectivity is seamless, experience is seamless for customers when they're using these services in the public cloud?
I'll take a stab at starting it. So one thing, just to make it super, this is a really big effort across multiple teams inside of Azure. We're building on top of the great stuff that Deepak's team has written and other teams have written, because there's a lot of great software-defined networking components. There's a massive physical network build-out machine that we can leverage. So that's great to help us accelerate. But at the same time, there are some technical challenges like, hey, at the end of the day, when we build out Azure, we assume, rightfully so, just like any cloud provider would, that you own all the physical components. You define what the servers are, you define what the switches are, you own the OS, and you can put whatever drivers you want on the hardware. Now all of a sudden you get into a world, and again, I keep using SAP as an example, but it's a common one and it's a popular one, where you have to run a particular OS to run SAP. And it has its own drivers, and your ability to get onto those servers as a cloud provider, you can do it, but it's now something additional you have to do. You're not just running the same OS across your whole fleet. You may have to run SUSE version 2 for SAP, and making your components work there, if you even can run them there, because now all of a sudden you start to bump up against other latency things. So there's all these constraints that come in play. So then things that we can leverage to help work on that, there's a lot of stuff that we have, as I mentioned, a lot of stuff in the software-defined networking. One of the things that we have that Microsoft is working with a lot of other companies on is Sonic, which is programmable switch software, so that we can actually do more programmability at the switch layer. We don't have to necessarily get on the servers. We can do some of the things we did on the server at different levels of the stack. So those are some things that we can leverage.
Yeah, I think this question dovetails very well with many good talks this morning about the different points of insertion for functionality, whether it's on smart NICs, the programmability on the smart NIC, or the programmability in the switches, as well as the telemetry information and things like that that can be gotten. I think all those tools are going to be needed for such a solution to be manageable, debuggable, as well as just overall ability to manage it as a service.
Yeah, I mean, I think just it basically just is those kind of things where, in some sense, the APIs, the telemetry from all of that, on the networking side is, I would say, even more important. I would say vitally important in these areas because, if you take a look at, some of these appliances that people want to go and run, customers want to run, you can't really go in and change the workload because these are, kind of, in some situations it might be locked down, or it might be like you don't get to kind of arbitrarily inject agents in there perhaps for various different reasons. And so then, when things go awry, really the only reliable way that you have of knowing is something going awry or not is actually the networking data plane. And so then that data plane in some sense is a critical element of enabling these things, and also just as you said, kind of debugging when things go wrong, and in some ways that effectively ends up being, if you will, the front door through which you kind of start doing that analysis.
Yeah, I think some of the telemetry information can also feed into other parts of the control and management system, such as where you place various workload and things like that to get the best of in terms of performance and locality and things like that. So.
That's actually a really interesting one, telemetry in particular, because again, these software packages come with their own telemetry. They come with their own monitoring. So people have been running SAP for ages in their data center, and it has its own suite of tools to collect data and give you dashboards. We have our own. How do we rationalize those two things? Even measuring latency sometimes is interesting. So these workloads come in with their own tooling because they've been in the field for a long time and they need to operate them. And how do we rationalize those things with existing tools and monitoring and telemetry that we have on our side and try to figure out how to converge and join that data into a way that's actually meaningful to help the bug issues?
Actually, I was just going to go there. I think all of you touched on it right away, which is when you're talking about telemetry and monitoring, there is sort of a built-in telemetry monitoring suite that we have from a public cloud perspective, and these workloads have their own. And I think what the challenges sort of you touched on are top of mind as I was thinking about this as well. And I think it seems to me that there's also sort of an integration required from this perspective with the partners that are working with us to get these workloads into public clouds, and sort of build these processes around making sure that when a customer that's using these workloads has an issue, that the public cloud providers and their monitoring solutions are talking to the partner solutions, if those exist, to make sure that there is sort of that end-to-end view. Is that something you guys have thought about, and how does that fit in how we're bringing these workloads into the public cloud?
Yeah, I mean, I can certainly speak from the Microsoft side. I mean, I'm also interested to hear from the VMware side as well. We certainly, I think, I guess I'll describe it as the specific workload being involved is absolutely a critical part of this overall journey. But some of those changes will happen more gradually, especially as you talk about more what I'll call older and or legacy type workloads. So the challenge always is going to be to come down to how do you meet the customer expectations of today while you've got workloads that are kind of more gradually changing. So I think it's probably a bit of both, where the cloud platforms have to evolve to, let's say, broaden their definition and sphere of influence, and the workloads have to change a little bit to also deal with the fact of this new reality.
I think in such complex systems, like what we usually do in computer science is that we have different layers of abstraction. And when there's a problem, you start debugging from the top layer, and then as necessary, you peel down. I think the interesting question here is that how much of the information you can automatically make available to people who are further up, because it's not just a matter of providing information. One also has to think about the security implication of certain information. I mean, this age of sideband attacks and things like that, information that at first sight seems okay may or may not be okay when people are able to actually infer things from it. So I think it's actually an interesting problem to make it an efficient process without having to involve many, many parties along the way.
Just to add a comment on the security side, it actually even gets inverted a little bit, because while there's security concerns from the customer side, there's also security concerns from the cloud provider side, because now you don't own the OS anymore. You're letting something that's wild into your environment, and how do you control and constrain that? So, because we worry about it too from our side, not just for the customer, but for our own business and other customers.
Great. So, the one other thing that I've sort of thought about when looking at sort of these type of workloads is there's also a model in the public cloud with network virtual appliances, right? And partners that we have that sort of supply specialized software for appliances that run on VMs in public clouds. I sort of wanted to get your comments on sort of how does that model compare with sort of these specialized workloads, and what are sort of the differences between the two, when we're looking at one offering these sort of network virtual appliances in the cloud versus integrating these workloads that are more bare metal.
Yeah, so my team has a few different hats, and one of the hats that we have is around NVAs, so we see both sides of it. Some commonalities are that there's these pre-existing things that customers have been running on-prem, have high expectations because they operated it, they know how it worked when it ran on-prem. They bring it into a cloud, and it's just a different world, so the things start to break. Differences, and I get into the challenges of when they break in a second, but the differences are really around, one's running on a server, and it's got very specific requirements around that server. The other stuff is, it's basically a VM. From our perspective, it's a VM image. It's running some stuff. The common things that we find, and it's really on the operations side, is these are really interesting multi-body problems. So what ends up happening, like in an NVA case, is a customer, I don't know, Bank of America, just making it up, is running a virtual appliance on Azure. If it breaks, who do they call? Do they call Azure? Do they call the NVA vendor? Do they call both of us? How do we coordinate that? That gets actually even exacerbated in some of these bare metal workloads, where frequently, again, using SAP as an example, a company who's running SAP doesn't actually run SAP themselves. They've outsourced that. They have a vendor that does that for them. So now you've got these multi-body problems when there's actually a live site incident of multiple companies trying to coordinate and make sure everybody understands their role and responsibility and collect data from all these different systems and troubleshoot it. So there's a lot of really hard problems around that right now, because we want to get these businesses going, and I think there's a lot of interesting technical and architectural challenges over time about how do we converge and simplify this stuff. And as Anand was saying, I think there's opportunities both for our clouds to evolve and for the vendor, whether it's SAP as a workload provider or F5 as an NVA vendor, to adapt their software and their practices as well. And there's a lot of good partnerships and learnings to share across the company. So collaboration is really important in this space.
Great. Any other comments there, Anand or Boone?
Yeah, I think in time, through practice,
Yep.
we'll learn to build a tool set.
It's a journey. It's definitely a journey.
Well, so I think the other question sort of that I had was, and then I think you sort of touched on it earlier in sort of some of the earlier themes as well. Is there's obviously the aspect of security when you're talking about these sort of workloads. There's also compliance. In fact, a lot of these workloads, are today used by customers for either compliance reasons, and therefore they're on-prem. For a workload like SAP, there's also sort of security reasons. What do we tell, as cloud providers and partners, what do we tell these customers in sort of building the case that you have these workloads, you can bring them into the cloud, integrate them, and the same level of compliance, same level of security that you need to have for these workloads you'll have in the cloud?
I mean, I think that the message in many of these cases is, I mean, it's quite similar to the kind of the overall, cloud migration message that typically, kind of customers hear, where, they want to basically feel that these workloads are as safe as they can be. And so in that sense, obviously an element of that whole thing is around the tooling and the infrastructure that we've got and the safeguards that various cloud providers might have to go in there and assert that. And those safeguards, and obviously the network, is a vital part of that. So, whether it be through the, in terms of the capabilities that the SDN offers, whether it be through rules, whether it be through firewalls, et cetera, and so on and so forth, all of those aspects are basically critical. And so then, you need something that is, here's an example in some sense of a case where you might have had capability in the cloud that was designed to work in a certain way that's basically got to get extended to be more inclusive to go support these kind of scenarios as well. And then of course, as part of that, there's all the various things from a compliance point of view where you've got to be able to go audit all of these things. You've got to be able to go, monitor that everything is up to date, is actually consistent with what you actually designed it to be. So there's kind of the design side, and then there's the audit side to make sure that everything is actually as performing and operating as designed. So kind of both are important.
I think in some cases there are also certifications that are needed if you want to run certain type of workload and things like that. So that goes all along, both in terms of the software as well as the personnel's training and things like that.
One of the other thing, when I was at this SAP conference, I heard from SAP very, very clearly telling customers get on the cloud. Whenever I talked to SAP customers around lunch tables like this, the common thing I heard was concern about security. And when I would dig into it, I said, well, what is the concern about moving your SAP database into the cloud from a security perspective? And really, there wasn't really anything specific. It was a control thing. So people felt like, okay, I'm running this thing on-prem. I've got my network isolated from the internet. People can't get on it. I feel really good about that. As soon as they're putting these things into clouds, cloud providers can tell them that, but they lose a little bit of that control, and that makes them nervous because the security is so important and the compliance is so important to them that they have to take this dependency that makes them a little bit skittish. So for us, it's a big part of what we have to invest in to make sure that as a cloud provider, again, whether it's Amazon, Google, or Microsoft, we're ensuring the security of these applications as they run in the cloud. And as I said earlier, we're making sure the clouds are secure against these workloads as well.
Great. Well, thank you. Well, these are sort of many of the questions that I put forward to sort of get your thoughts on. I want to leave some time for we have a few minutes left, and if there are questions in the audience that anyone wants to bring up, now would be a great time. We can use the next few minutes to try and get those questions in.
Hi. Wonderful conversation. Thank you. I'm just a little confused as to what part of this is bare metal. Because, you talked about telemetry, and sure, I understand it, but isn't that service orchestration versus bare metal orchestration? And, I consider bare metal as, you take a machine or take a device out of the box, and you attach it. And then you've done your telemetry, and you can provision it, right? And this is coming all the way from, there's no operating system on that particular device, or there's nothing on it. Is that your definition of bare metal, or is it something different?
So to me, I think there's two different definitions that we talk about when we consider bare metal. One is, and really look at it from a customer's perspective, not necessarily as an infrastructure provider's perspective. And it has implications on us as infrastructure providers. But the two buckets are, the customer gets a server, and they can do whatever they want on it, put whatever OS they want on it, put whatever application they want on it, do whatever they want on it. The other one, which is really more of what we talk about in this scope, is the customer gets a server, can only put certain applications on it,
right?
Whether that's SAP or something else. that adds some constraints to the problem. Sometimes constraints are good as an engineer. You want to know what the size of your box is. Sometimes not good to have constraints because they're really hard to achieve those constraints. But we talk a little bit more, when we talk about bare metal in this context, it's more of that latter bucket. So the customer's not getting a bare server. They have applications that require a bare server of some type.
Okay, that makes a lot more sense, right? Because my question was, if you're talking about the former, there's got to be something on that metal box that you can actually talk to.
Yep.
Right? Whether it's hardware specific on a service processor or it's some very small version of the OS that can boot up, right? And so that actually clarifies it. So just to understand, when you talk about bare metal, you actually mean the latter part, and that is, there's something that actually resides on the metal, and you can then talk to it. That's not really, there's something there, whether it's a hypervisor or an OS or something to that end, right? Mm-hmm. Okay.
Yeah. And just to continue on that just for a second, the reason that it's hard even in the second case is it's unlike the rest of the fleet. So the rest of the fleet, we run whatever OS we want, we run our own hypervisor, we run whatever we want, our own agents on there. When these bare metal workloads come in, they have their own requirements, they have to run SUSE, whatever version, and we can't necessarily just put our own stuff on there. So that it constrains what we are, the tools in our toolbox.
Well, I've got my signal. I think we are out of time. If there are no other questions, I would like to thank the panelists for stepping in and I think providing us some really good insights into sort of these different workloads and getting sort of our heads wrapped around what these are and how they, what they mean to integrating in public clouds. So thank you very much for coming on, and thank you all of you for listening in.
Thank you.